So I'm very pleased to introduce today's speaker, Carroll from the University of Wisconsin. So Sean is one of those very, very few people in the world who founded an entire new field of science. So the modern evolutionary developmental biology, known popularly as the EVA-DEVA. So that's the area of biology that tries to apply ideas and techniques from developmental biology and molecular genetics to understand evolutionary and ecological questions. And so Sean has made many important contributions to that new field. So particularly it's largely thanks to Sean's work that it's now generally realized that the evolution of new traits is linked not so much to the evolution of new genes as to origin of new interactions among pre-existing genes. And Sean's work has really illustrated many of these instances of changing regulatory interactions among genes. And so Sean has a very active lab that's producing a lot of very interesting stuff, only some of which he'll talk about tomorrow at a more specialized talk. And in recent years, he's been devoting more and more of his time and effort to popularizing the latest ideas and discoveries in evolution for people outside of the academic communities. So he's written several very good and very popular books about evolution, and recently he's been working on producing radio and TV shows about evolution and science in general. And I think he's become one of the most prominent ambassadors for evolution and science in general to the general community. And so today, that's what he will talk about.
I swear I hit that button. I'm hitting it. I got so many buttons to push. Anyway, I hope that short film puts you in the mood for some adventures. Thank you, our team, for that very generous, sometimes true, but mostly not, introduction. Thanks to the Davis community for inviting me here, for all of you for your hospitality and spending time with me over these couple of days, and for coming to this talk late this afternoon. The search for the origin of species has entailed a series of truly epic adventures over the past 200 years. And I've had a great time chronicling those stories in a new book. You get to guess the title. And today what I want to do is share with you some of those adventures and really celebrate the explorers who undertook them. Now, I think author C.W. Sarum described adventure best as a mixture of spirit and deed. And my hope is that you'll be inspired by the great spirit of these individuals and come away with an even greater appreciation for the magnitude of their deeds. Now, throughout this year, the world is celebrating the achievements of Charles Darwin, no doubt our greatest naturalist and the leader of a far-reaching scientific revolution. And my talk today is in part my contribution to that party. But my agenda is a little bit broader than that. While Darwin's works and his voyage are well known, and rightly so, the birth of the theory of evolution by natural selection and its early growth and acceptance owe a considerable debt to two other men, Alfred Wallace and Henry Walter Bates, who undertook even longer voyages under more difficult circumstances than Darwin's 5-year voyage around the world. Now, all three of these men had a lot in common. They were all young Englishmen when they left their home country for the tropics. Darwin was 22. Bates was 23. Wallace was 25. They were all prodigious collectors. I think they all shared some form of OCD, obsessive collecting disorder, because they pretty much grabbed, pinned, pickled, kept specimens of every creature they encountered for the rest of their lives. But most importantly, as collectors, they developed an appreciation for the variety of individual species. And from this really hard-earned knowledge, they evolved from mere collectors into scientists. And they started to ask not just what creatures existed, but how those creatures came to be. And those questions led each man to unique discoveries. So what I want to do today is I want to take a little while to walk in the footsteps of these three great explorers and see how the creatures that they encountered led each of them to their respective insights and to the making of the theory of evolution. And then, briefly in the second part of my talk, I want to talk about where evolution is now today. I think their voyages and their work really mark the first golden age of evolutionary biology. And I want to briefly explain why I think that today we're in a second golden age. Now, of these three men, no one's adventures and experiences better fit that description of spirit and deed than Alfred Wallace. And my tales this afternoon are going to begin with Alfred Wallace in the Amazon. Now, Wallace had several reasons in traveling to the Amazon, not the least of which is that he hated his day job. He had quit schooling around age 13 and worked a series of jobs, but he was really passionate about natural history and about collecting. And that's how he met Henry Walter Bates. And through this shared hobby of collecting, they shared the latest information about where you could find various creatures all across England. And they also sort of shared their dreams of traveling abroad and of seeing some of the richness that was being reported by travelers to other parts of the world. And so they hatched a scheme. And their scheme was they wanted to travel to the Amazon, which they had read was very rich in terms of species, and really, first and foremost, to build a natural history collection for themselves. But the obstacle to that was they had no money. And so the only way they could come up with to sort of get there, they weren't professional scientists, they had no connections, they were working jobs totally unrelated to science, was to sell duplicate specimens back in England to museums and Victorian collectors and to use those proceeds to pay their expenses while they were traveling throughout the Amazon. Now, they had another objective in going to the Amazon. Wallace was very well read. And in the 1840s, in England in particular, there was a lot of discussion circulating about this question of the origin of species. And the fundamental question was whether species were created by God, specially created and immutable, or had arisen through natural laws. And so Wallace said explicitly to Bates, let's go to the Amazon and gather facts towards solving the problem of the origin of species. So off they went in 1848, and they arrived on the coast of Brazil in Para, and they spent about the first year exploring this territory, and then split up to cover more ground. I think that's a Victorian way of saying they got on each other's nerves and decided to explore different tributaries of the Amazon. So Wallace continued up the main trunk of the Amazon and then up the Rio Negro, and we're going to catch up with Bates a little bit later in the talk. But let's follow Wallace's path. He went 2,000 miles inland, further than any European had ever gone, such that by 1852, he was way up here, deep in the Amazon. But by 1852, he'd had it. 4 years of collecting, the arduous journey heading up the Amazon, carting around specimens, shortages of food, tropical diseases, they were wearing him out. In fact, he was laid up for several months here with a fever, and he was also being worn out by the fact that he was keeping alive about 3 dozen animals. So Wallace's idea was that he was going to cart all the way home to the London Zoo representatives of the fauna of South America. So he had with him a woolly monkey and a macaw and a toucan, and he was keeping these things in little cages and feeding them every day, despite the fact that he could barely keep himself alive. So by 1852, he said, okay, this is it. I'm worn out. I want to head home. So he headed back down, all the way back down those 2,000 miles, collecting these crates of specimens that he had set aside, and eventually made his way back to the port in Para, Brazil, with his animals. And he found a brig called the Helen that was headed back to England, and boarded the Helen and set sail for England. And, after 4 years away from home, he starts thinking about, a warm bed every night, and 3 square meals a day, and bread and butter, and things like this. And well, in terms of what happens next, I'm going to let Wallace tell you some of this. This is a letter actually in Wallace's hand, where he explains that he was maybe somewhere around 700 miles east of Bermuda on the Helen when the captain came to his cabin and said, "I'm afraid the ship's on fire. Come and see what you think of it." Now, Wallace was still in a pretty weakened state, but this got his attention. So he popped up out of his cabin, he went to the hold, and sure enough, it was smoldering, and he knew it could erupt at any second. So he realized there wasn't much time. So he dashed back to his cabin, and all he could do was grab a small tin box, throw in a few shirts, throw in a few drawings of, for example, some of the Amazonian fish that he had drawn. Another talent of early naturalists. They were generally good artists. And he went to the life ropes and grabbed a rope, had his tin box, and went down the rope towards the water. But he actually lost his grip and burned his hands on the rope. Then he hit the salt water with those fresh burns on his hands, swam over to the lifeboat, climbed in, and realized it was leaking. And then from that position, in an open lifeboat in the Atlantic, he watched the Helen burn, all of his animals perish, and his specimens sink to the bottom of the Atlantic. So, as he realized, of course, all of his collections were in the hold, and all the reward of his 4 years of privation and danger were lost. There may be a few field biologists in the audience. I'll just let them soak that in for a minute or two. But Wallace couldn't dwell on what he had lost. The issue, of course, immediately was survival. Here he was, 1852, in an open lifeboat in the middle of the Atlantic. Well, day after day, continued in the boats. We were scorched by the sun, my hands, nose, and ears being completely skinned and drenched every day by the seas and spray. We were constantly wet and had no comfort at night. We had a short allowance of water, which left us constantly thirsty. Now, as Wallace sat in this boat, now this is a drawing from a book about 30 years later that cataloged various famous shipwrecks, so the Helen at least was infamous in some way. Sitting in that lifeboat, at some point I think it had to occur to Wallace, how did I get in this predicament? What am I doing here? Well, since one of his major objectives was to go to the Amazon to gather facts towards solving the problem of the origin of species, if he was going to blame anybody, it would be this guy, Charles Darwin. Because Darwin already knew the answer to the problem of the origin of species. He knew it 15 years earlier. He just didn't tell anybody. So the irony, of course, was sort of lost on Wallace. So how do we know that Darwin knew? What did he know? Well, to understand that, let's retrace a few of his stops on his voyage and some of the key documents of those times. So we know what Darwin actually knew and hadn't disclosed to the rest of the world, even by 1852. So remember that Darwin's voyage started in 1831, just after Christmas. He was 22 years old, and they headed for South America. And one of his earliest important stops was on the coast of Argentina. Now, Darwin was well-versed in what word is that? He was well-versed in geology. He had gotten a lot of field experience just before he had left Cambridge. And so he came across some fossil mammals, and spent a considerable amount of time excavating them and shipping them back to England. And it turns out on the coast of Argentina, what Darwin found is he found things like skulls and jaws and teeth and vertebrae and even pretty intact remains of one of these beasts. And what was most notable about these mammals, as they were reassembled in England by experts and word trickled back to Darwin, was they were all gigantic. They were huge. And things like, for example, this giant ground sloth named after Darwin called Mylodon, it would tower over me. And so it was clear that these animals, this was a sloth-like beast, this was sort of an armadillo-like beast, they were llama-like beasts, but they were all larger than the living forms that he found in South America. So it would occur to him much later, but the geological relationship between the extinct creatures he found in the ground and the living inhabitants of South America that he was seeing in his travels was going to be an important set of dots for him to connect. Now, he kept traveling. Now, you got to appreciate in terms from Darwin's point of view, this voyage was going to be much longer than he expected. So he signed up for what he thought was going to be a 2-year voyage. About a year into the voyage, he realized it was going to be much longer. Now, he was seasick the whole time. And he never overcame that seasickness. So he wrote home, in fact, to his mentor, Reverend John Henslow, the botanist who had trained him and actually nominated him for this voyage. He said, I know not how I will endure it. But Henslow said to him, keep up your courage. If you ever think of quitting the voyage, take a while to think about that. I'm sure you always will find something, to keep your interest. And he did. So he endured rounding Cape Horn. He climbed the Andes, experienced earthquakes, saw humans in their most savage state. He stuck with the voyage. There was always something new. And eventually, 4 years into the voyage, the Beagle steered away from the west coast of South America and headed towards the Galapagos Islands. Now, Darwin was really excited about headed towards the Galapagos, not for the creatures there that we all know about, but for the geology. It was going to be his first chance to see volcanoes. So he wrote home excitedly, I'm going to see some volcanoes. And when he arrived in the Galapagos, what he saw was this. He saw islands populated by what he described as antediluvian-looking creatures, like these giant tortoises or ocean-going lizards. I mean, who ever heard of such a thing, swimming lizards? And then there were other things like sort of this humdrum mockingbird and some other birds on the islands. But Darwin, immediately his first impression, he thought the islands, they smelled funny. They were really hot. And after 5 weeks of being on the Galapagos, he was more than ready to leave for places like Tahiti and points west. So while these islands are inextricably linked with Darwin's name, privately he thought they reminded him of what hell was supposed to be. So on he went. And as he kept traveling west, he was hoping, of course, eventually to reach home safely. And the Beagle went to Tahiti, Australia, South Africa, and just about when he thought they would be steering up for Europe, the captain of the Beagle, who was rather obsessive about this mission of measuring all sorts of bays and ports around South America, steered instead back to South America. So you can imagine Darwin's despair at more time yet out on the ocean. In fact, he wrote home to his family. He said, I abhor the ocean and all ships which sail on it. But he decided to make good use of this time. And what he started to do was he was gathering up his notes. His intention was, remember, he's now 26, 27 years old, was that he was going to rely on experts in England to help him interpret the geology, the paleontology, the zoology, the botany, all the specimens that he had collected. So he started taking his rough field notes and organizing them. And he started organizing in the last couple months of his voyage his ornithology notes. And he thought back about some of the birds of the Galapagos Islands, and particularly the mockingbirds, which he had noticed these 3 slightly different forms had occurred on different islands. And as he thought about this a little more, and this is actually a page from his ornithology notes where he's organizing these various birds by specimen number and adding rather orderly comments. His field notes are much messier than this, but this is something that he's really trying to do a diligent job of organizing for some future ornithologist to take advantage of. As he thinks back about these birds, and he has his first eureka moment. He writes in his notebook, he says, when I see these islands in sight of each other, and possessed of but a scanty stock of animals, tenanted by these birds, but slightly differing in structure and filling the same place in nature, I must suspect they're only varieties. If there's the slightest foundation for these remarks, the zoology of archipelagos will be well worth examining, for such facts would undermine the stability of species. That's the sentence right there. Undermine the stability of species. His first eureka moment. Species may not be stable and immutable. They may change. This idea grips him as he arrives home in England, and he starts a series of notebooks, private notebooks he's carrying around in his pocket, jotting down thoughts in a stream of consciousness fashion. He describes this phase as mental rioting, just hurling things as they come to him, as he reads, as he thinks about what he's seen on his voyage. So here's a few notes out of those notebooks to get a feel for what Darwin was thinking. So in 1837, just that first year after the voyage, he writes in this notebook called B, we may look at Megatherium, a giant ground sloth, armadillos and sloths, as all offsprings of some still older type. So he thought, well, you have the living inhabitants up walking around the forest floor, and below them in the ground are extinct relatives. But there must be still older types. Species have ancestors. Organized beings represent a tree irregularly branched, Some branches far more branched, as many terminal buds dying, going extinct, as new ones generated. And then he thinks about the fact that, well, he sees extinct sloths and extinct armadillos and living armadillos in South America, but he didn't see those things in Australia. He didn't see those things in South Africa. Those certainly weren't in continental Europe. He thought, maybe the similarity of animals in one country, or for example, the similarity of birds on different islands, they're owing to their springing from one branch. And then on the next page, Darwin draws, obviously the most famous picture he ever drew, what's truly a new system of natural history, where species are descended from ancestors, and those ancestors from previous ancestors, and so forth and so on, just as children are descended from their parents and grandparents and great-grandparents, etc. That there's a tree of life. And this, for Darwin, represents the end of special creation. He knows that species change. He knows that there's a natural explanation for the origin of species. But he's not going to tell anybody. He's 28 years old. He's barely been home a year. This is absolutely contrary to the doctrine he was taught as a student at Cambridge. It would be heresy. And he knew heretics weren't treated well. And furthermore, you can come up with your own explanations for why he might suppress these thoughts. Did he feel like he had enough evidence? Maybe not. But also, this would be quite an affront to the very people who put him on that boat and whom he's relying upon for their expert input and for their support as he sort of gains his scientific feet underneath him. In the next year, following this line of mental rioting, more reading, more thinking, he conceives of the idea of natural selection, but he doesn't tell anybody. He's very convinced by 1838 that species change, and he has one of the mechanisms for that, natural selection. And he's feeling a bit exasperated because the more he thinks about it, the more evidence that he reviews, the more convinced he is of his thinking. And here he is, he realizes that what the new geology that has explained landforms of the earth as a product of natural processes, not catastrophic floods, and the movement of the planets in the heavens as a matter of physics and not a matter of being pushed around by somebody up in the sky, that people had already been accepting the new science of astronomy and geology, but not biology. And here's a telling quote from a notebook late in 1838, sort of expressing this exasperation in one of my favorite quotes. He says, we can allow satellites, planets, suns, universes, nay, whole systems of universes to be governed by laws, but the smallest insect we wish to be created at once by special act. So of all the beetle species and everything else he had collected, he thought, no creator would bother themselves with just a tiny little insect. These have come about by natural means, just as the great landforms of the earth have come about, just as the planets and their orbits have come about, all guided by natural laws. But he's not going to tell anybody. He has a golden opportunity to do so, because at the very time that he's jotting down these private thoughts and filling notebooks with them, he's writing his account of his voyage on the Beagle. So he and Fitzroy, the captain of the Beagle, and a previous captain are writing their account of this voyage. It's going to be published together in this big book, long title, Narrative of the Surveying Voyages, etc. Darwin's contribution to this is known as the voyage, what we call today the voyage of the Beagle. So he gets to some of the creatures that he's seen, and he gets to the Galapagos archipelago. What's he going to say? He's going to dodge it. He says, it's clear that if several islands have each their peculiar species of the same genera, when these are placed together, they'll have a wide range of character, like all those finches with their funny little faces. But there's not space in this work to enter on this curious subject. That's it. He knew species changed. He wasn't going to spill the beans. Now, when Alfred Wallace, younger than Darwin, reading this later, reads this passage, he sees that the great naturalist Darwin had left the question of the origin of species wide open, had made these observations, but had not put forth a single theory to explain what he had seen. To Wallace, the problem was wide open. He didn't know that Darwin continued thinking on this line. And by 1842, Darwin had written what he called his pencil sketch, a 35-page explanation of his species theory. No one else knew either. Darwin didn't show it to anybody. And then he expanded that in 1844 to a 230-page essay with a table of contents that looks a heck of a lot like the table of contents of a book that's going to come out many, many, many years later. So Darwin knew. Darwin was fully convinced. He had 230 pages of reasoning and evidence. But he told his wife, Emma, this may be worth something, but only publish it after I die. So should I die, please see to it that it's published. So he was willing to have his thoughts disclosed, but only if he was gone and not there to receive the scorn that he felt was sure to come his way. So Wallace was privy to none of this. Obviously, had Darwin disclosed what he was thinking some 15 years earlier, we might never have heard of Wallace, and Wallace would not be bobbing there in the Atlantic in a lifeboat. But there he was. Now, of course, if he hadn't been rescued, we wouldn't have heard of Wallace either. So he was rescued. So after 10 days and 10 nights, a vessel was seen, and by night we were on board her, much rejoiced to have escaped a death on the wide ocean, whence none would have ever come to tell the tale. So I'm reading these quotes from this letter, which I want to give you a little more explanation about. This is a letter, the actual text of the letter, that Wallace wrote to a friend back in Brazil from the rescue ship. He wrote it in installments over a series of days, and from the beginning sort of recounts his tale of heading back to Para and boarding the boat with his animals, etc., and the whole ordeal. And a little bit later on in the letter, he explains to his friend, he says, 50 times since I left Para on the coast of Brazil have I vowed, if I once reached England, never to trust myself on the ocean again. Of course, if he'd kept that vow, we wouldn't have heard of Wallace either. But he confesses a little later on in the letter, but good resolutions soon fade. So here's Wallace, despite his loss, despite his 4 years' effort, where he has nothing to show for it, despite his near-death experience, he's not satisfied. When he gets back to England and can get his affairs in order, he starts thinking, where else am I going to go? I want to go collecting. I don't have my natural history collection. I don't have an answer to that question of the problem of the origin of species. This is 1852, 16 years after Darwin completed his voyage, many, many years after Darwin had written privately his account of his species theory. And of course, it's going to be Wallace that's eventually going to make Darwin go fully public with his ideas. So where to? Well, Wallace is thinking, let's see. I'm not going to go back to the Amazon. His friend Henry Walter Bates is still there and has that covered, as though one person can cover the Amazon. So he says, I want to go someplace where it's going to be rich. I think I'm going to head for the jungles of the Malay Archipelago. So he heads to the Malay Archipelago. He reaches Singapore in 1854. Now, contrary to never trusting himself on the ocean again, he works his way west to east. He makes 96 island-to-island crossings, totaling 14,000 miles. He collects over 120,000 specimens that this time will be secure. Now, when he arrives, he has pretty much the same challenge as the Amazon. He wants to collect for himself, but he's got to collect really good stuff and sell the duplicates. So he starts hunting for treasures. What is he looking for? He's looking for things like this. Bird-winged butterflies, named for their giant wingspan, but coveted for these beautiful markings on their sort of velvety wings. But he's not just, yes, he's collecting, and it's a practical concern of a paid collector to figure out where these creatures are. But he's paying careful notice to where these things are. And as he collects more species of bird-winged butterflies, and this is an actual specimen box of Wallace's that is in the Natural History Museum in London, he finds these different species, but he realizes, I'm finding different species on different islands in the Malay Archipelago. And I never saw bird-winged butterflies in the Amazon. He went 2,000 miles into that jungle. Never saw a bird-winged butterfly. Saw hundreds of other species of butterflies, but no bird wings. So he starts thinking, what might this mean? Closely related butterflies on different islands in the Malay Archipelago, but not in other parts of the world. Well, Wallace has none of the inhibitions that Darwin has. And he starts sending dispatches from the Malay Archipelago to natural history magazines and to scientific journals. And in his first year in the Malay Archipelago, he writes this paper. Look at the title. On the law which has regulated the introduction of new species. Now, time frame starts to become important here. This is 1855. Okay, so I'm going to show you what unfolds over the next 4 years. But this is 1855. And from the island of Sarawak, he explains what he describes as his Sarawak law. What is that law? He says, you know, the most closely allied species are found in geographical proximity. Bird wings near bird wings. And so I think every species has come into existence coincident both in space and time with a pre-existing closely allied species. Remember, this is a pure amateur. Ended schooling at age 13. Oh, yeah, you might be interested in this one. The best mode of representing the natural arrangement of species? A branching tree. He's seen nothing of Darwin's writings. This is what he's coming up with. So he sends this paper in. It gets published, as you can tell. What does he hear? Grumbling. Stop that theorizing. Send us more bird wings. Okay? So no one pays any attention. Wallace keeps moving. Now, he doesn't know what he's going to find in these islands. They're not well charted out. He needs help. So who's he going to call upon for help in finding the treasures in the forests of the Malay Archipelago? Well, he calls upon native experts, like the Dayaks of Borneo. Now, they're known to be a fierce tribe, but Wallace also knows they have sort of their own interest in natural history and in collecting. So, fortunately, none of these are Wallace's head, or we would have never heard of Wallace. Okay, so he gets help in finding various creatures, and he's getting quite an eyeful as he goes island to island to island, working west to east. And he moves across the archipelago. He notices, as he takes a short trip, just from the island of Bali to the island of Lombok, the beginnings of a pretty dramatic changeover in the fauna that he sees on the islands. So whereas on the western islands, like Sumatra, he sees things like tigers, and on Java, rhinoceros, and on Borneo, monkeys and orangutans, in the jungles in the east, he sees things like tree kangaroos and cuscus, marsupials. You think, well, this is something kind of strange. He says, you know, it's almost as though there's a line dividing the western and eastern islands. And what he's seeing over here are fauna more characteristic of Australia, marsupials and kangaroos, and these are fauna more characteristic of Asia. So Asiatic fauna over here and Australian-type fauna over here. What could explain this distribution? And he says, well, my Sarawak law. He says, I think, and he'd been following the latest thinking in geology, he says, I think at one time these islands were connected, and that then after they separated, these islands, these animals adapted to the different conditions on these different islands. This Australian-related fauna. Species come into existence with closely allied pre-existing species. Whereas these animals are all related to Asiatic fauna, fauna of mainland Asia. So Wallace was right. We refer to this today as the Wallace line, and he's the founder of biogeography, explaining the geographical distribution of animals. But for Wallace, this now was the end of special creation. In fact, he points out in a paper he writes about this in 1857 that this is completely at odds with what the creationists would predict, or the model of special creation. Because the model of special creation was that animals were specially created to fit a habitat that they were then placed in, sort of like pieces on a chessboard, and then they lived for some particular time in that place. So that doesn't make any sense. These jungles over in New Guinea look just like the jungles over in Borneo. Why would you have up in an arboreal habitat, why would you have up in the trees monkeys over here and tree kangaroos over here? Doesn't make any sense. No, he looks for more a historical explanation. And why would you have, for example, kangaroos over here in the jungle and kangaroos over here in the open savanna of Australia? If there wasn't a historical explanation, here's two totally different habitats, but clearly related species. His Sarawak law. So he's convinced species change. Species give rise to new species. So the next question for him is how? He keeps moving further east to an island called Ternate. And there, on an 88-degree day, baking in a malarial fever, wrapped in a blanket, in a dilapidated hut, somewhat hallucinating, it occurs to him. And as soon as his hallucinations and fever passes, he writes it down. How do species evolve? He says, well, 8 years of experience in the jungle, what's it taught him? The life of wild animals is a struggle for existence and to provide for their infant offspring. A battle. Not this harmonious picture that had been painted in Europe and England in drawing rooms, everything in its place. No, it was a battle. And perhaps all the variations he sees with no two members of any species identical must have some definite effect, however slight, in the habits or capacities of the individuals. And he thought, a variety having a slightly increased powers must inevitably in time acquire a superiority in numbers. Sorry about that. He called this on the tendency of species to depart indefinitely from the original type. As you'll see, fortunately, that's not the language we all adopted for this idea. But he's on the right track. So he jots down this note, and he thinks, well, maybe this is worth publishing. So he decides to send it to a naturalist with whom he had started a correspondence the year before, and says, well, if you think it's worthy, please pass it along for publication. So he sends it to Charles Darwin. Darwin's a bit shocked. Why is he shocked? Well, to really appreciate the shock, I wanted to dig this out for you. I want to show you some quotes from what Darwin was writing a year earlier. Again, this is rough manuscript, not even seen in the final form of The Origin of Species. What was Darwin writing at home at Down a year earlier, February, March? He was writing chapter 5, entitled The Struggle for Existence, as bearing on natural selection. And what did Darwin explain in this chapter? He said, all nature is at war. The struggle very often falls on the egg and seed or on the seedling. Any variation, however infinitely slight, if it did promote during any part of life, even in the slightest degree, the welfare of the being, such variation would tend to be preserved or selected. When Darwin receives this paper from Wallace, he says to his friends, geologist Charles Lyell, botanist Joseph Hooker, he says, Wallace could not have written a better abstract of my theory than if he had had all my writing before him. I've tried to emphasize here the parallels in thinking. Great minds think alike. What had these two men seen? Well, Wallace had seen, in the Malay archipelago, butterflies that were specific to individual islands. And those signified to Wallace just what the birds of the Galapagos had signified to Darwin. Wallace had read a social economist named Malthus, who described that the limit on the increase in human populations was war and famine and death. And Wallace thought, gee, that probably applies in the natural world. Darwin had read the same work. Darwin, in fact, immediately upon reading Malthus, had conceived of natural selection, written it down. So their journeys had shown them a lot of things about the way the world really was, and they came up with similar ideas. So Darwin, however, was quite distracted at the time. This is June 1858 when Wallace's letter arrives, and Charles Jr., his 10th child, is suffering with scarlet fever and will die that month. So he's too distracted. He just passes Wallace's letter on to Charles Lyell and says, will you take care of things? And what they decided to do was to publish Wallace's paper along with a brief excerpt from Darwin. And those papers were read July 1st, 1858 in front of the Linnaean Society. Here they are. The debut of the theory of natural selection to the scientific world. Wallace wasn't there. Wallace was still thousands of miles away in the Malay archipelago. He didn't know his paper was even being presented. They didn't take the time to write him and ask for this. Would have taken months back and forth to deciding what to do. They just did what he said and got it published. Darwin wasn't there. That very day, July 1st, 1858, he buried Charles Jr. in a family cemetery. So here's the debut. And as the legend goes, the person presiding over this meeting noted in the minutes, nothing much happened that day. Nobody paid any attention. Of course, Darwin had a little extra incentive now to finish the great book that he had been working on for so long. And the next year, hurled himself into completing his treatment of his species theory. And we all know what that results in. Now, of course, people pay attention. November 1859, when The Origin of Species appears. It's a great synthesis. But most important, it's completely accessible to lay people who can read his argument, who can review the evidence, which Darwin very persuasively argued both sides of many points to show how he had reached his conclusions that were not at all hasty about these matters. At times, of course, I think many of us admire it because I think it's phrased really eloquently. Now, this book, of course, heralded the end of creationism and marked a revolutionary new view of nature, a battlefield in which the better competitors thrived. It also set the agenda for the next 150 years, and I hope for many of these people in the audience for at least another 50 or 100 years. Many, many questions that Darwin did not have evidence that he would have loved to have had. And one of the questions that pops up right away is this new idea of natural selection. Naturalists are thinking, is natural selection, this process Darwin describes, is this really strong and sensitive enough to shape the fine differences among species? Well, fortunately, just a little bit earlier that year, our old friend, Henry Walter Bates, dragged his rather sorry and broken carcass home from the Amazon after 11 years. 10 of those spent on his own. Now, the only experiences that he would admit to was being robbed, being left essentially without any clothes or shoes, which he said is a bit of an inconvenience in the tropical jungle. And many bouts, of course, of some identifiable, some unidentifiable diseases. But he collected more than 14,000 species in all, more than 8,000 new to science. And to understand a little bit about Bates's spirit, when he left the Amazon, he said the saddest day he ever spent in his life was the day that the boat taking him away from the continent, where he lost sight of the shoreline and those palm trees and everything. And he realized that he was leaving a place, he said, of perpetual summer for the familiar scenes of gray, drab, foggy, rainy England. So Bates, when he arrived that summer, he starts organizing his specimens. He has no position in science. He's been gone 11 years, but he had no position when he left. He had no position when he returned. In fact, he was going to spend 3 years living with his family. But later that fall, Darwin's Origin of Species appears and gives Bates a framework for thinking about everything he had seen in the jungle. And he realizes, I've got some gems for the great naturalist. Now, Darwin had relied quite heavily on the analogy of domestication, of artificial selection by humans for crops and livestock as a description of natural selection. Bates, in the jungle, realized, I think I have got a glimpse into the laboratory where nature manufactures her new species. Well, this was welcome news to Darwin, who was taking a battering in the public press over his book on the origin of species. And he starts saying, Bates, tell me more. Tell me more. So they strike up a very warm correspondence. Darwin, very encouraging, but extracting details out of Bates, out of every letter. And this is the way Darwin worked. He had correspondence with people all over the world, and he very gently and very politely milked everybody for every nugget of information they could give him. So Bates says, okay, Darwin, here's what I saw. He said, I noticed that in many places I went, I saw totally harmless animals resembling more noxious forms. Things like this beetle that resembled a wasp found in the same vicinity. Or I found things like this caterpillar that at one end had a head like a small viper. So much so that when I carried this caterpillar into the village, everyone ran off frightened. And he said, the more I think about it, why would totally harmless animals resemble poisonous or noxious forms? He realized that they must be gaining some sort of advantage. But no creature taught Bates more and meant more to him than the butterflies of the Amazon. Now, here was a master butterfly catcher. In one area alone, he caught 550 different species. And he noticed, on closer inspection, that things that looked like the same species weren't. And things that didn't at all look like close relatives were close relatives. Let me explain. So on the top here are two closely related butterflies. They belong to the same genus called Leptalis. But this butterfly very closely resembles another butterfly in a completely different family of butterflies. And this butterfly resembles another butterfly in another completely different family of butterflies. And what Bates noticed was that when he handled these butterflies, they gave off some kind of noxious gas, that when he had them drying on his table in the jungle, that unlike other butterflies, these weren't carried off by lizards and by birds. And when any of these butterflies were flying in the jungle, they weren't pursued by birds. And he thought, these butterflies would seem totally harmless. They don't give off the noxious gas, etc. They must be gaining an advantage by mimicking these other forms we refer to as models. Furthermore, when he looked at these butterflies in close detail, he said, they're all different from each other. Some resemble the model better than others. It's not like these butterflies are stamped out as the way a press makes a set of new toys, all identical one to another. They're slightly different. And some of those that might resemble the more noxious butterflies would be gaining some advantage. And he explains that to exist at all in a given locality, our Leptalis, these butterflies up here, she must wear a certain dress, and those of its varieties that do not come up to the mark are rigidly sacrificed. The poor mimics are eaten, but the good mimics are protected. And I believe the case offers a most beautiful proof of the theory of natural selection. Well, guess who else thought it offered a most beautiful proof of the theory of natural selection? So this paper is published by Bates, and Darwin writes him a note. This is the actual note, funny enough, in the possession of Case Western Reserve Library in Cleveland. Never quite know where you're going to find a Darwin gem. And he tells Bates, in my opinion, it's one of the most admirable and remarkable papers I ever read in my life. And Batesian mimicry becomes important, fresh, just-in-time evidence for the idea of natural selection. How else would you explain life imitating life? Life imitating other forms and gaining some advantage. And Bates explained this only happened when they existed in the same vicinity. There wasn't something in northern Brazil that resembled something in southern Brazil. He only saw these mimicry relationships in the same geographical district. Darwin wanted to make sure nobody missed this point for Bates, so he even wrote a review of Bates's paper, published it in a natural history magazine, saying, this is as close as we're going to come to seeing this process of natural selection and the birth of a new species on the planet. Now, Bates published this in 1862, and finally that's the same year that Alfred Wallace comes home from the Malay Archipelago. Now, there's important relationships between these men. Darwin had been rooting on Bates. They had a very warm friendship. Ever since their correspondence in 1857 and 1858, Darwin and Wallace had been corresponding. They had a very candid exchange about how each other felt about the way the papers were published. It was a very warm relationship. So they're going to be close friends, and obviously Wallace and Bates had been friends since back in the 1840s in their insect collecting days. So they, from that point on, the great mutual admiration and great stake in promoting this new theory of evolution. And they do so for the rest of their lives. This is how you often see them, right? As the old men. But of course, they did their central experiences of their lives were as young men. And their voyages and their writings and their work and their theorizing, they mark a golden age of evolutionary biology. But the last thing I'd want to imply here is that this was the end of the golden age. Far from it. Over the next 150 years, and I'd say particularly in paleontology, but in many other branches of biology, many expeditions ferreted out much more about the history of life, and of course that's still going on today. And for around $20 you can read about some of those other adventures. But I'd submit that right now we're in a second golden age. And it's a golden age where we're no longer restricted to just looking at these remarkable creatures, but we can see how they're made and how they've evolved. So I think we can see from the laboratory into how new species are made, new forms are made. And modern biologists are collectors too. They're putting together a menagerie, much like the one Wallace tried to bring home from the Amazon. We have things like sloths and armadillos and platypus and wallabies, even a chimpanzee, but we're not stuffing these and sticking them in museums. We're not taking them back to zoos. We're taking their DNA. And we're putting together an archive, a DNA record of evolution. There's something like 52 mammals in that today and still growing. In fact, there's a likelihood that's going to reach 10,000, at least 10,000 vertebrates, as I know. There's about 2,000 other species in our DNA record. And from this DNA record, biologists are working to pinpoint exactly how the fittest are made, how the different forms of the animal and plant kingdoms have evolved. And as we mine this massive record, I think I can say that we share the same sense of wonder and surprise and discovery as the pioneers, only fortunately, we don't have to barf our way through the workday or, dodge malaria or headhunters, just peer review. Talk about cannibals. But we no longer stare at creatures, like this marvelous butterfly, just as Bates did, merely mesmerized by its external beauty, because we can now see the genes in action responsible for making these beautiful patterns and diverse forms. And in terms of the fossil record, what could be better than the sorts of fossils like these that Darwin collected? Well, how about DNA from fossils? New ways of peering into the past that certainly Darwin could not think of. Can you actually slide that one in for me? Thanks. Could not think of, but that few modern biologists would have even thought possible until recently. But those tales are for another day, and I'll tell you a little bit more about the DNA record of evolution in a more functional way tomorrow. My task today was to highlight where this all started. And among the past adventurers, the one we celebrate this year and above all is Darwin. So why? Well, I'm sure the biologists in this room would have all their own personal reasons. But I'm going to give the last word to Wallace on this. How did Wallace really feel? And I think the most honest way we can understand Wallace's thoughts is to look at what he told people, his confidants. You okay? Yeah, you can just leave it. That's all right. If it's loaded, we're good. I'll take care of it from there. Thanks. It's just hard for me to do everything else at the same time. It's moving buttons. So it's what Wallace told his most intimate friends. How did he feel about that publication alongside Darwin? How did he feel, for example, about The Origin of Species? Well, Darwin sent him a copy of The Origin of Species as soon as it was published. We still have that copy. In fact, it's in London with all of Wallace's annotations. He said he read it over like 5 times, and he's just marking up the margins and exclamation points, etc. And after he finished the book, he wrote a letter to Henry Walter Bates. So Wallace is still in the Malay Archipelago at the time of this letter. He's, in fact, back on the island of Ternate after voyaging about a bit. He has beautiful handwriting, so it's pretty easy to figure out what he was saying. And he writes to his friend, "Dear Bates, I know not how or to whom to express fully my admiration for Darwin's book, its overwhelming argument, and its admirable tone and spirit. Mr. Darwin has created a new science and a new philosophy, and I believe that never has such a complete illustration of a new branch of human knowledge been due to the labors and researches of a single man." That's how Wallace thought. And that's what he thought for the rest of his life. He dedicated his own book, The Malay Archipelago, to Darwin. He always referred to this theory as Darwinism. He was a pallbearer at Darwin's funeral. He devoted a chapter of his autobiography to Darwin. He felt very well treated. He was just fine. I think it's maybe the treatment of Wallace over the last 100 years that we have to think about, where since he died, he outlived Darwin by 30 years, since he died roughly 100 years ago, that our textbooks and historians of science have just not given Wallace nearly as much attention as Darwin. So I think Wallace has faded a lot to just getting small mention in textbooks. But Darwin, of course, went on to do much more after The Origin of Species. Much more work, of course, dealing with the process of evolution and the origin of humans. So that's why we celebrate his birthday as a great naturalist, a great leader of a new revolution, I think a great human being. So for his birthday, I want to offer a couple of thoughts. I'm going to try to do the lighting of this right. But anyway, my first is that more people will appreciate the great spirit that drove young Charles and many other men and women to leave behind loved ones, to risk their comfort, their safety, all to just follow their dreams and to pursue the unknown. And secondly, that more people will come to embrace the real grandeur and beauty in the story of life that they've revealed. So I hope you feel as I do. And if you do, well, then this little birthday card that we've composed, well, it's for you too. And I hope you enjoy it. Take a little time for questions, or okay, take a little bit. Okay. I don't know what the time constraints are. Our team's going to have to tell me. So, any thoughts, questions from the U2 fans? I think you all know what that was. Yeah.
What correlation is there between Darwin's raising of pigeons and his theory?
Well, I think that was part of his pursuit of sort of testing his ideas. So when he got back to England, and especially as he got set up at home and down, he made the acquaintance of quite a few breeders, including fellow pigeon breeders, and he started breeding pigeons himself. And he realized that by close control of parentage, you could influence what forms, what traits were could be bred for and could be bred pure. So he saw that as a experimental test of his ideas of natural selection, that breeders were doing essentially the same thing intentionally, consciously, as was happening in nature under other forces. So I think it was more of the phase, not of his first conception of the idea, but his long testing phase of anything he could think of to test some of these ideas about species formation or about adaptation or natural selection. He did. He asked himself questions of, how did these plants, for example, get to the various islands like the Galapagos? And he said, could seeds survive long journeys in salt water? So he put seeds in salt water and left them on the shelf for 6 months and then planted them and saw, in fact, they could grow. So it was just part of that inquiry phase where Darwin was testing out his ideas through all sorts of means. But later, it was really the mockingbirds and then sort of conviction through the finches that led him to be convinced that these fine differences between species were arising naturally. Yeah.
Would you say that you are an evolutionary biologist or an evolutionary bench scientist?
Well, I guess I'm not sure of the distinction.
No, that's why I asked.
Well, maybe you can tell me better. I don't know if you understand that.
I find it really funny to sit in this church to control of nature watching your film.
In what way?
Well, we're sitting in the middle of this very fancy genome building.
Mm-hmm.
And then you play a song and show wonderful images of animals. So why the hell do we need this?
Well, I think it's kind of both. I think, okay, now I understand your question a little bit more. So, I think if you ask a lot of people, and you can divulge yours, a lot of biologists, why do they become biologists? I think they're drawn to nature. But when they pursue it as a career, they may be drawn to asking questions about nature that drive them inside buildings, and to pick up pipettes, and so this is maybe a little bit of a way to remind us of sort of the soul inside all of biologists and everyone interested in nature, maybe to keep that fresh in mind. So I don't know if that's so. I'm committed to bench science and to preserving what we just saw. Yeah.
I really appreciate your review of these great naturalists. Try to follow their writings and infuse what little I could of their insight into some of my own work. And if I may speak somewhat metaphorically, I think they are probably some of the best evidence for special creation. If we think of Darwin as the first attempt at a second coming, but it turned out he didn't quite have the personality for it, and so whoever was happening back by the planet almost 2 millennia later, well, I better instigate Plan B, Wallace, and Bates out there, sort of the wild card. Maybe he can help too. And I think there is some virtue in that metaphor, in that if we do consider the insights of Darwin and his cadre and their relevance at both the material, scientific, and spiritual level, for me personally, the insights I gained from Darwin are a big part of what make my life on this planet meaningful and really help structure my relationship to it and how I want to live my life materially and scientifically.
And I had a comment not a couple days ago, just from someone mentioning that maybe Darwin, more so than the other naturalists, was aware of the philosophical implications of what he was brooding over. That he, whether that's his Cambridge education or his upbringing in an upper class, well-to-do family, that where ideas were circulating, that Darwin, much more so than Wallace, was aware that this was going to hit society like a ton of bricks, and that many people were going to wrestle with it, very, very deeply, and that I think he was very, very aware of that, and in his writings, first it guided what he was going to say publicly, but privately, you can look through his diaries, his notebooks, especially his correspondence with intimates, that he was well aware that this was reshaping a view of life, as sort of modest and as tight-lipped as he wanted to be most of the time. Nonetheless, he was well aware that it was having that impact.
It offers a lot of guidance into appreciating, what life is, what it can be, and where we can go from here if we work from the standpoint of his insights and those that are based upon his insights.
And I'll add, I think he was also a model of tact and diplomacy, which is always in short supply, I think. In the back, yeah.
Yeah, we described the story of Darwin and his theory, and we jump forward up to the age of modern genomes. It's very exciting, but so where does the modern synthesis fit into this story and its three magi?
Well, I think, it was a huge step forward to integrate genetics into evolution as it did, and to sort of harmonize genetics and paleontology and systematics as the modern synthesis did. Obviously, I'm taking a little liberty in describing today as a golden age, but I think it's a discrete age because I think it's an age where the power of the tools allows us to get unprecedented quantity and quality of data about the process of evolution, whether that's talking about trees and the relationship of species on life, or actually the process of adaptation, the diversity of forms. So I don't mean any slight to the modern synthesis, but I think the modern synthesis sort of lacked a clear-cut catalyst that vastly increased the wealth of knowledge about the process. So I don't. It's kind of an unfair comparison to make. But if I said this is the third golden age, it just doesn't work very well metaphorically, because then I'd have to tell you about the second golden age, and that's another 10 minutes of a talk. So. Yeah, so there's no slight meant to the people in the 1930s and 40s that brought forth what we'll describe as modern evolutionary theory. But it did not, anyway, I think you understand what I'm describing. I'd like to characterize this as collectively a lot of people on a new adventure of seeing how evolution works in unprecedented depth with unprecedented confidence in terms of drawing conclusions and understanding mechanisms at work. And that's where I'll draw a little bit of a stand. Yeah.
Along those lines, can you talk a little bit about blended evolution versus atavistic and its relation to Darwin?
Blended evolution with respect to Darwin and atavisms?
Yeah.
So, there were lots of ideas circulating, and that Darwin had to deal with right after the origin of species, before or after the origin of species, and about how characters were inherited. So one of the things that Darwin was very up to date on, very knowledgeable about from embryology, I think Thomas Huxley had helped him a lot, was to understand things like vestigial structures. And so that was key evidence to Darwin, again, of descent with modification, is looking at things at vestigial structures. In terms of atavistic changes, so changes of a reversion to a more ancestral state, do you have something particularly in mind where Darwin's writing about atavisms?
Actually, I was talking about atomistic.
Atomistic. I'm sorry. I thought you said atavism. Sorry.
Oh, that's good too.
Yeah. Yeah. Sorry. Different thing. Yeah. So you want to amplify that a little bit? Otherwise, I may talk for a while without getting anywhere near your question, and that's dangerous.
I just want a sense of how disturbed Darwin was about this.
Just how disturbed Darwin was by this thinking?
Because I'm not clear on how much was known about what direction you could take and what that might mean to the theory.
Yeah, I think Darwin he didn't have a mechanism for heredity, which was a big gap, and he didn't have the fossil record he would have loved to have had. So, for example, Darwin talked a lot about, how are we going to sort of explain the connections between forms, and there should be these transitional forms that bridge the great groups of, for example, animals. He was very animal-oriented in a lot of his writing. And so that in some ways also set the agenda. In other words, how does inheritance work? Because obviously it's going to be a big part of his theory. And where are the fossils? Where are the transitional things? For example, if humans are derived from apes, where are the transitional forms? And so for a lot of people, that was the inspiration to go look for these things. Eugene Dubois in the 1880s finding a transitional form between, a remarkable story, by the way, which I recommend, who threw a magic dart at the world map and ended up finding what we call today Homo erectus. Things like Archaeopteryx, something that's had mixed characters of birds and reptiles and things like this. So I think that what Darwin was most concerned about was, as in the next 2 decades after the origin of species, how did evidence coming in from geology and paleontology and other natural history, how did that jibe with what he had put forth? And so I think that was his utmost concern, was how well was his theory going to hold up. And he had, that thinking also led him to other domains of thought. He realized, for example, that how would you explain the really extravagant forms in the animal kingdom, like peacock tails and giant horns on antlers and things like this? And that led him to a huge theoretical breakthrough of the idea of sexual selection, that the mating game would lead to such extremes in the world. So I think you could look at his next 2 decades of thinking as working out several other ideas, working out several other problems. For example, the descent of humans, that were not, satisfactorily explained or were not explored in The Origin of Species. So I don't think he was disturbed. I think he was just wondering, not wondering. I think the question was, would there be anything that would come along that would smash his theory? And the answer is no. Much came along that bolstered his theory. Is that help you a little bit? Okay. All right.
And one thing about the second coming, too, we should also, I guess, remember, though, that they're in close proximity with one another, and they maybe came from the same tree.
I'm certain they came from the same tree.
Oh, yeah.
I'd bet all the money in genomics they came from the same tree. Yeah, sorry.
I seem to remember hearing that Wallace wasn't able or willing to go to that extra step to apply natural selection to humans.
That's correct.
Can you talk about that?
Yeah, so Wallace was reticent, let's say, to apply it to humans, and he still thought that humans were something special above the animal kingdom. Wallace, in his later life, he became interested in spiritualism, seances, things like this. So this probably did something to undermine some of Wallace's long-term reputation, and that he became interested in things that we would perceive, and were perceived at the time, as a little more fringe. And, Darwin kind of fretted a little bit whether, sort of Wallace was killing off their very own child, right, with some of these other excursions. Because, Darwin certainly, it was very important to Darwin, and it's very clear in his writing in The Descent of Man, that humans were part of the animal kingdom and not above it, and descended from lowly in his descriptions, ancestors, and that we still bore in our bodily frame the marks of this ancestry from lowly forms. So that's where they differed. But, as gentlemen, those differences did not rupture their friendship.
You've obviously spent a great deal of time going through Darwin's correspondence, and this I'm wondering if you have any new insights into one of the great mysteries, and that is Gregor Mendel's solution to the heredity problem. And my understanding is that Darwin never slid open the pages of the journal that containing the paper Mendel wrote. But is there any hint from the correspondence that anyone else was trying to bring this to Darwin's attention?
Not that I'm aware of. There may be other people here who could shed light on that. But Darwin's idea of genetics was way off the base, and I'm not aware of anyone that brought him closer to the truth in the remaining 2 decades he was alive. So I know pretty much just as much as you just related. In terms of reading a lot of Darwin's correspondence, it sure beats watching CNN. So I just thought I'd point that out. thing that we owe so much to are these people that have spent 30 years putting together the Darwin Correspondence Project, and there's transcripts online of so much of Darwin's correspondence, and then especially the growth of Darwin online. All of these manuscripts, diaries, notebooks, etc., and transcripts are available. And I just sort of watched over the last couple of years that I was working on this project, I watched that even grow further still, where I'd go back and visit and go, oh, goodness, there's a manuscript I didn't know about, and be able to see it in original form. So I just want to point out, anyone to explore, and certainly to teachers, I think like Darwin Online is an enormous teaching asset to have people go look at real notebooks, written in his hand on a particular day, saying a particular thing. I just think it has so much more impact than seeing the digest, or if that at all, in something like a textbook. But thank you for that little entries for my sermon. I appreciate that. Is that back over here? Last one, maybe?
Yeah. Along those lines, my understanding is that part of his reservation initially for publishing was that his wife had held strong religious beliefs, and he had some reservations about offending her, and to some degree. Did he write about that with other people, or was that just something he internalized and kept to himself?
Well, it's something you can tell in their notes to each other. I think that's something that biographers, and this is, I think, really well developed in Adrian Desmond and James Moore's book called Darwin, the Life of a Tormented Evolutionist. It's a biography written about 1994, and I found it riveting. It kind of it sort of aroused my whole interest in this phase of history. And they are very tender notes back and forth between Emma and Charles, and Emma explaining in note form, her concern over their life in eternity. That if Charles disclosed these things and they were heresy, that what would happen to them? And they had this very, I have not been a student of Victorian marriages, but he worked out a home for 40 plus years, and he fathered 10 children, 7 of them lived to adulthood. They had this whole family life surrounding the home. He and Emma played backgammon reportedly every night, and they kept a lifetime tally of scores. I don't recall who I actually don't remember exactly who won. So they had this really close relationship, and they had this shared experience. Anything that would bring. He knew her for almost all his life because she was a first cousin, Emma Wedgwood. And then they had this experience where their daughter Annie weakened and died at age 9, and all those life experiences together. They had a really close bond, and so this was tough for Charles. If he thought anything he was doing would bring grief to Emma, that would be really, really tough. At the same time, I think she understood as the traffic of scientists came through the house of, Lyell and Hooker and Huxley, that something big was afoot, and that as she got to know maybe them, she understood that they were concerned that his ideas actually be disclosed. So I think it was a juggling act. And right off the bat, there's lots of, anyone can have a hypothesis here about what Darwin was thinking. I do think there was something to say in terms of the immediate conception of the theory that he would have paid a terrible price, probably scientifically, because he had seen what had happened to other people who had put forth such a radical idea. And secondly, he was really mindful of his feelings towards Henslow and Sedgwick. These were ordained clergy, that were the faculty at Cambridge. They had, put him on that boat and given him every opportunity in life. And I think that would sort of be like spitting in their face. And, he had great feelings for Henslow. He had intended to study divinity under Henslow when the voyage came up. So I think it was lots of consideration for those people in his life, and a little bit of practical consideration about what would happen to a young scientist whose, Voyage of the Beagle made him famous. And had he disclosed his theory, it would have been, rougher for him. At the same time, in hindsight, had he disclosed his theory, then the next 20 years of natural history would have been interpreted, in that light. And fossils would have had a fresh interpretation, not the ones that Owen and others were imposing on them. So it's an interesting thought experiment to run. But. So should we wrap that up there? And all right. Thank you, everybody. So bench top tomorrow.